Suppose you want to have $7,000 for retirement in 25 years. Your account earns 9% interest. How much would you need to deposit in the account each month? And then how much interest will you earn? So since we're making monthly deposits, this is a savings annuity. And we don't know what the deposit is. We need to calculate that, but we know what the future value is. So we're going to flip the formula. And the formula flip to find the payment is going to give us our future amount for however many years we need times that prorated rate, the APR over the number of periods per year. And then in the denominator, we get that parentheses where we see that part of the compound interest formula. -1. So that's a flip of the formula where we know the payment and calculate the future amount of the annuity. So here my PN is really 25, so let's call it P25. That's my $700,000 I want to have in the future. I have a rate of 9%, which is 9/100ths. I'm making monthly payments and monthly interest. So my N here, sometimes we use the letter K for that. That is going to be 12. And my years, sometimes that's also a capital N, that is 25. So for this formula, I'm going to have my 700,000 that I desire for the future times my 9%, 9/100ths split into 12 months per year. And that is divided by my double parentheses here, 1 plus that 9%, 12 months per year to the power 12 times 25. 12 months per year for 25 years. We subtract 1 from that after doing the power, close the parentheses on the whole denominator. So I think it's a good idea to see the formula, enter your values, then try it on your calculator. And because we have a multiple of the payment or the future value, that doesn't have to be in the numerator. To be in the numerator, you type the fraction first. 700,000 times parentheses our rate, 9%, split over 12 months in a year, divided by parentheses 1 plus our rate, split into 12 months, get to the right of that to close the parentheses, then use your power, parentheses, because you have to do a multiplication in the power, 12 times 25, close the parentheses, get out of the power position before you subtract the 1, and close the parentheses. And again, on most calculators, you need all of these parentheses. Some calculators can use fewer and still get the right answer. So the claim here is that if I make payments of $624.37 every month for 25 years at 9%, I'll have $700,000 in the future. So 624.37, let's make a note of that. So that's my monthly payment. Now to figure out how much interest I earn, so the first payment I put in makes the most interest over time, and then each additional payment has, one less month consecutively for how much it's going to earn up until the last payment only earns interest for a month. So every payment I put in earns a slightly different amount of interest. How do we sort all that out? Well, we know for our total payments, that each month we pay $624.37. Now that's going to happen every month, 12 months in a year, for 25 years. So this calculation right here are my total payments. Let's see how that compares to what I'm going to end up with in the account, the 700,000. So I'm going to take my rounded version of that answer instead of using the previous answer button, $624.37. And I'm doing that 12 times a year for 25 years. So I'm paying into the account a total of $187,311 for this account. So 187,311. So that's what I'm paying into this account, and that seemed to come out even, remarkably. Now, but I end up with 700,000, so the difference has to be the interest that I earned. So for part B here, if I take that 700,000 that I'm going to end up with, subtract the 187,311, that difference should be my interest earned. Let's see what we got. So I'm going to take my 700, 700,000. I'm going to subtract that previous number as it is there. And it looks like then the interest on the account over time was quite a bit, 512,689. So we earned quite a bit of interest on that account. If you want to double check that we have the right payment, you could go back and put it in the regular annuity formula, which is basically the flip of the one I have here. So to check that those payments will give me 700,000 with accumulated interest, I'd use the formula like the one above here. So that formula would be my 624.37 in monthly payments times parentheses, 1 plus my 0.09, my 9%, 900ths over 12. That's going to be the power 12 times 25, 12 months per year times 25 years. Get out of the power, subtract 1. In the denominator, we divide by our rate over 12. And now notice I didn't get exactly $700. That's because, again, we had to round this to the nearest cent above, and I get pretty darn close to 700,000. I'm within, what, $5.10 of $700,000. $5 out of 700,000, not a big deal. So it does look like I have the right calculations there.